Hey, hey, it's Dr. J. Talking about multiplication and division today, specifically of integers. So we'll have the rules of negatives and positives and all that stuff. I'm going to start off with just sort of a philosophical question that might help motivate this lesson. What is multiplication? So what do I mean when I say, 3 times 5, and I'm using my algebraic multiplication dot? What do I really mean? And the answer is, you probably don't think about this very much, but I do. When you say 3 times 5, hopefully you don't even have to think about it. Just bam, 3 times 5, you already know it's 15, right? But the answer is multiplication is actually repeated addition. Yeah. So there really is no thing called multiplication. It's really just addition that you did when you were 10, and you just remember that if you go 3 plus 3 plus 3 plus 3 plus 3, you're going to get 15. Yeah. Or an easier way to do it would be 5 plus 5 plus 5, and you're still going to get 15. So either way, you could say you're going to add 3 5 times, or you could say you're going to add 5 3 times. But either way, you're going to get 15. And basically what you do is, as a young person, or a person that's just learning mathematics at whatever point in your life that you're learning your multiplications, you just memorize this, right? And then you never, ever had to do it again, right? I did that once, so I don't ever have to do it again. I know that every time. And so now you just go 3 times 5 is 15, and you don't typically think about what you actually did, okay? And that's true for all multiplication problems. So if you ever don't know a multiplication fact, if you can't just remember it instantly, then you can always do it the hard way. Add it up, and figure out what the multiplication is. All right. Now, I'm sure you all have heard that before, but this actually applies to integers. Yeah. So today we're going to start multiplying positives and negatives. So what would it mean if I said 3 times negative 5? Okay. Now I could use a dot, although if I'm using parentheses, then the dot is not necessary. Yeah. Notice if you're not using parentheses, the dot would be very important because you don't want it to look like subtraction. So the parentheses are very important. Whenever we're talking about negative numbers, we're going to need the parentheses. So what does this mean? This means add negative 5 3 times. That's what that means. That means you're going to add negative 5 3 times. So negative 5 plus negative 5 plus negative 5, if you added it 3 times, you would get negative 15. So we typically memorize this as a positive times a negative is a negative. Or another way to think about it, because you always have 2 ways to think about it, you could subtract negative 3 5 times, which would also be negative 15. This one's a little tougher because you got negative 3, negative 3, negative 3, negative 3, negative 3, but go ahead and count that up. If you subtract negative 3 5 times, that would be the same thing. So it's the same as negative 3 times positive 5. Okay. So in either case, whether it's a positive 3 and a negative 5, or whether it's a negative 3 and a positive 5, it really makes no difference. Either way, you're going to get negative 15. Now here's the tricky one. Here's the one that it really takes, a stretch of our imagination to be able to understand why this one is true. Or what is the truth behind this one? A negative times a negative. And again, I could put a dot in between, but since I'm using parentheses, the dot is not necessary. So what would that mean? Well, this would mean subtract negative 3. So subtract negative 3 5 times. I'm running out of space here. Remember, adding and subtracting are the same thing. We learned that in the last lesson. So subtracting, adding follow exactly the same rules. So I'm saying subtract negative 3, subtract negative 3, subtract negative 3, so on and so forth. Let me make sure I got the right number of times. 1, 2, 3, 4, 5. And remember, we learned this in the last lesson. When you subtract a negative, that is the same as adding a positive. And so you're just going to add 3, and you're going to get positive 15. Or the other way to think about it would be subtract negative 5. This would probably be the easier way to do it. 3 times. And by easier, I just mean less writing. It's not really any easier. Unless writing is, complicated. So this would be positive 5, positive 5, positive 5, which would still be 15 either way. Now, I want to make something very clear. This is just the philosophy, the underlying structure of what's going on. I certainly don't expect you to do this. What I expect you to do is do it this way. Negative times a negative is a positive. All of this on the repeated addition and subtraction side is just philosophically, why is this true? Why is it true that I'm memorizing this rule? And what type of safety net do I have? If I get a problem that I can't just do mentally, is there a way of backing it up to something simple and solving it that way? All right. And I really hope that I get that out there, because if you get stuck on a complicated problem, you need to reduce it down to a simple problem and solve the problem that's much simpler, and then you can solve the more complicated problem. Okay, so to go forward, you sometimes have to go backwards a step and take a look at what's actually going on behind the curtain. Okay. All right, so let's summarize this of the rules. So if you have a positive times a positive, that is a positive. A negative times a negative is also a positive. A positive times a negative is a negative. So this is the result here. And a negative times a positive is a negative. Simple way to remember this: if they have the same signs, the result is positive. If they have different signs, or you could say opposite signs, the result is negative. Okay, so those are the summary of multiplication. One thing I would hope that you appreciate is how simple these rules are. Yeah? You don't have to worry about the absolute value of the number. You don't have to worry about whether or not you're going to the right or whether or not you're going to the left or whether you're going up or down. Addition and subtraction, you actually have to stop and think about it before you do the problem. But with multiplication and division, you really just kind of look at the problem and snap it out. Yeah. Okay, so go ahead and make sure you have these rules either affixed in your hard drive up here, or if you don't, have a little note card that you can refer to. If you do use notes, at some point you should put them away so that you can give your brain a chance to try it on its own. I'm going to erase those or move on and multiply some numbers. Oh, we already did that one. Let's do a different one. Just trying to make them a little interesting, although they're all going to be relatively simple numbers at this point. If the numbers start get really big in the hundreds and the thousands, obviously I wouldn't be using mental math. But for numbers that are, this size, we can just do them in our heads. So we got a negative times a negative is a positive 30. And 5 times 6 is 30. Positive times a negative, negative 48. 12 times 4 is 48. If you have to actually multiply it out. 7 times 8 is 56. And this is a negative times a positive, so that's a negative. 11 times 12, that's one of those weird ones you probably haven't done since you were little. It's 132. 132. 11 times 12. If you don't have that one in your head, you can write it out like this. 1 times 2, 1 times 1, put a placeholder, 1 times 2, 1 times 1. And as soon as you do it, you'll go, oh yeah, I already knew that. It was 132. All right, so there you go. I want to point something out about parentheses. Sometimes we don't use parentheses. So in my next example, I will sometimes not use parentheses. So the number that's out in front does not necessarily need a parenthesis. So here's some cases where I can omit the parentheses altogether. Only if both numbers are positive, you will not need any parentheses at all. Okay. You do, though, need to use the dot if you choose not to use parentheses, because if you don't use the dot, it looks like 126 or 126, and the dot should not look like a decimal point. So be careful that you don't accidentally put it down on the floor here. You got to make sure it's kind of in the middle of the numbers. Okay. Typically, the number that's out in front doesn't need parentheses around it. In front, I mean to the left. Mathematically, that's the front. Yeah. However, the second number does need parentheses because think about it. If you take away the parentheses, it looks like subtraction. I will answer this question once and for all, although I'll probably answer it again in the future. How do I know whether I need parentheses? Right? So if we're in the classroom, good question. How do I know? Take them away and see what happens. Yeah. If you take away the parentheses, like look down here, do I need parentheses? Well, I don't know. Do you need them? Take them away. Yeah, you need them. Right? Otherwise, it looks like negative 98. Now, you could get rid of the parentheses and replace them with a dot. That would mean the same thing. So this one actually does have an alternate form, you could put -9 in parentheses, then 8, or you could put -9 times 8 that way. Either way, you're going to get the same result. Okay. Same thing here with the 8 and the 4. How do you know that you need the parentheses? Well, what if you got rid of them? It would look like -8 minus 4. And that's not what this is. This is -8 times. I mean, you could put a dot, but that still kind of looks like subtraction to most people. So the parentheses are what we refer to as insurance. How do you know whether you need insurance? Well, get rid of it and see what happens. Yeah, you'll find out really quickly that you wish you would have had the insurance. Okay, so let's go through the rules. Positive times a negative is a negative 54. Negative times a negative is a positive 32. Positive times a positive is definitely a positive 72. This one, negative times a positive is negative 72. And it doesn't really matter which way you write it. I guess I could call this one E. I really want to. Okay. And then before I move on, I'm going to do a note on opposites. If n is a real number, then negative n is the opposite of n. So we read this as the opposite of n. Yeah. Can also be written negative parentheses n. Or, now that we have multiplication, you can think of this negative sign as a -1 multiplied by n. So -1 times n is the opposite of n. These are all different ways of saying the opposite. So negative n, negative n, I like to pause when I have parentheses, -1 times n, or -1 times n. Yeah. So all of these are equivalent forms of the opposite of a real number. In particular, I know I always use the word real number, but really what we're talking about is integers. We will have a much broader discussion about real numbers in general. I would just take it one chapter at a time. So in chapter 3, we're talking about integers. All right, and that's just a quick note on opposites. Yeah, so multiplying by -1 is equivalent to finding an opposite. If there are more than 2 factors, then count the number of negative factors. If there's an odd number, the answer is negative. I don't like to say answer. I like to say result. You can say answer, but I'll say result. If there's an even number, the result is positive. Okay, so these are the factors. All right, count the number of negative factors. There are 3 negative factors. So that's an odd number of factors. So the result I already know is going to be negative because there's an odd number of negative factors. All right, now let's do it. Once you've counted the negatives, you can just ignore them because you already know that your answer is going to be negative. All right, you already know. So now just multiply. 5 times 2 is 10. 10 times 6 is 60. 60 times 1 is still 60. So the answer is, or the result is, negative 60. Now this rule I just recommend memorizing, but I mean you can really think about it. This rule is just an extension of the original rule. So if there's an odd number, then the even number, so these guys are even numbers, they become positive, and then you have what we call the oddball. That's really why it's called odd, right? It's the one that's left out. It's the one that doesn't have a partner, right? So it's not even, it's odd. Yeah, it's the third wheel here. So you have these two guys go together, they become positive, and then you've got this leftover negative. And again, it doesn't have to be these two that go together. These two could go together, the -5 and the -6, and then the oddball would be -1. Yeah? So no matter what, if there's an odd number of factors, somebody is always going to get left out in the cold, right? That's what odd means, right? It means that there's somebody or something that doesn't have a pair, doesn't make a pair. Okay, so we'll count the factors, the negative factors. There are 4 negative factors. By the way, after this example, I won't write that down anymore. I'll just do it mentally. I don't expect you to write all that down. So there are 4 negative factors, so you know the result is going to be positive. All right, so you know this. So go ahead and do it. 2 times 6 is 12. 12 times 8 is 96. 96 times 3 is too big for the average brain. So the last one, I'll do it all out. 3 times 6 is 18. Carry the 1. 3 times 9 is 27. Plus 1 is 28. 288. And you do not need to put the plus sign. But if you do, I'm not going to mark it wrong. It's just going to look weird. Plus 28. I mean, sorry, plus 288. I certainly wouldn't mark that wrong, but it's just an unnecessary. Save that for some time when it's actually necessary. Okay. So you know this is positive, 288. All right. I guess that'll do it for multiplication. The next thing is division. Same rules as multiplication. That is really cool. It's a buy one, get one free. If you memorize the rules for multiplication, you're going to get the rules for division for free. A positive divided by a positive is a positive. A negative divided by a negative is a positive. A negative divided by a positive is a negative. A positive divided by a negative is a negative. In fraction form, it would be plus over plus is plus. You actually don't need the parentheses when you're in fraction form. That's nice. A positive divided by a positive is a positive. Yeah, negative divided by a negative is a positive. You can still put the parentheses if you want. Although oftentimes when we do fraction problems, we just don't use parentheses. And over here it would be a negative divided by a positive is a negative, and a positive divided by a negative is still a negative. And again, if you think it's neater, I think it sometimes looks neater to have the parentheses, but we often don't use parentheses in these forms. Okay, so division has two forms. Sometimes we write it using the old school division sign, and sometimes we write it using a fraction. The rules take up the whole board here, so take a good look. Okay, so division, old school division. So negative divided by a negative, I already know it's going to be positive. 9 goes into 27 3 times. In this section, in fact, probably for the rest of chapter 3, you can quote me on that, the rest of chapter 3, there will be no decimals or fractions, there will be no remainders. I might give you a problem that's a fraction, but it will always turn into a whole number or an integer. 64 divided by negative 4, I already know it's going to be negative. 4 goes into 64 16 times. 16 times 4 is 64. If you're not sure, we'll multiply it out. Negative divided by a positive, I already know the answer is going to be negative. 81 divided by 3 is 27. 3 goes into 81 27 times. If you don't believe me, do it. Yeah, you can actually write it all out if you have to. I'm not sure if everybody memorized that one. 3 goes into 8 2 times. 2 times 3 is 6. Bring down the 2, bring down the 1. 3 goes into 21 27 times. So now you know it. Sometimes a student will say, I don't know that one. And then we'll do it, and they'll go, oh, yeah, I knew that. It's all psychological. All right, this one we're dividing by negative 1. So you don't actually have to divide because you're dividing by 1. It's just going to become the opposite. Oh, so here we go. Another form of opposite. So if you divide by negative 1, you also get the opposite. Fraction forms. Again, I mentioned this earlier. I typically don't use parentheses with the fraction forms. Sometimes I'll do it if I really want to emphasize something. I'll use parentheses as sort of a show-off kind of, hey, look at me. There's parentheses around me. I'm important, But if there's not any kind of, showy thing like that, if I'm just trying to exercise a principle, I typically will save the pen and not write the parentheses. All right, positive divided by a negative is a negative. Negative divided by a negative is a positive. Negative divided by a positive is a negative. And a negative divided by a negative is a positive. Again, another form of opposite. So think of all the different ways of doing opposites. There are so many ways to talk about opposites. There's just the basic way, negative n. There's the basic way with parentheses. There's the multiplying by -1. There's multiplying by -1 with parentheses. There's dividing by -1. And then there's a fraction with -1 in the bottom. All of these mean the same thing. Opposite, 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 opposite. Be careful with this one. I often get students that will write it backwards. They'll put the -1 on the left and the n on the right, and that would be backwards. The number on the left is called the dividend. It goes on top. The number on the right is called the divisor, and it goes on the bottom. So if you write it backwards, it's actually incorrect. So be careful. Division is not as forgiving as multiplication. Yeah. Multiplication, if you write it backwards, it's still correct. Yeah. We're going to get more into that later. Okay. Next, we're going to do exponents. We've done all the division problems. So, a to the n power means a times a times a n times. Right? A is called the base. N is called the exponent or the power. They mean the same thing. Exponent, power means the same thing. I forgot what I'm up to. 1, 2, 3, 4, 5, 6, 7. So 2 to the 5th power. 2 is the base. 5 is the exponent. And I'm going to multiply it 5 times. 2 times 2 is 4. Times 2 is 8. Times another 2 is 16. Times another 2 is 32. I typically just go from left to right. If you prefer grouping, you can do grouping. 2 times 2 is 4. 2 times 2 is another 4. 4 times 4 is 16. And then bring this 2 up. 16 times 2 is 32. If you prefer grouping, you can do it that way as well. Or you can go 2 times 2 is 4. And then if you remember from the lecture on prime numbers, 2 times 2 times 2 is 8. So you automatically get 4 times 8, and that still gives you 32. You're going to get 32 either way you do it. Be careful with negatives. I say this in all my classes, so don't take this personally. If this problem was given to any of my classes, I would say exactly the same thing, because negatives, especially when we're talking about powers, cause a huge problem. If there are parentheses around the number, then you are going to multiply negative times a negative times a negative times a negative. If there are parentheses. So this literally reads negative 3 4 times. Negative 3 times negative 3 times negative 3 times negative 3. Multiplied by itself 4 times. That's 4 negatives. So the answer is positive 81. 3 times 3 times 3 times 3 is 81. All right. This one has no parentheses. So it does not mean negative 3. It means the opposite of 3 to the 4th power. So it's really all about how you say it. All right, and I don't listen very carefully. Listen to part A, how I say it. Negative 3 to the 4th power. Let me say that again. Negative 3 to the 4th power. Now listen to how I say part B. Negative 3 to the 4th power. So it's as if the negative is separate from the 3. So I'm going to do 3 times 3 times 3 times 3, and then I'm going to put the negative sign out in front, and these are separate. Yeah. And if that bothers you, you could just make it a negative 1, because we talked about that. Multiplying by negative 1 gives you the opposite. So that would give you 3 times 3 times 3 times 3. That would be 81. And then times negative. There's only one negative. So the result is negative 81. Okay. That's really the only caution that I have about exponents. I guess the other caution is really common, but I mean, it's common, but I just don't really think you're going to do this. But let me just say it anyway. I think you're all going to be very uncommon when it comes to this. Do not go 3 times 4 and get 12. All right. That's typically, when I say it's common, I mean it's common if you're going fast, if you're not thinking, if you're just kind of rushing through things, and you go 3 and 4 and you put 12 just sort of out of habit, or sort of reactionary, knee-jerk reaction. I think I've been warning you about that kind of thing enough that you'll probably hear me go, don't do that, so 3 times 4 would be 12. That would be totally wrong, and there's no way to save yourself at that point. You've driven off the cliff at that point. Okay, next we're going to put it all together. Follows a lot of my other lessons. What do we do next? Order of operations. So the old way, which is still valid, there's nothing wrong with doing it the old-fashioned way. Please excuse my dear Aunt Sally. Yeah, and so that stood for parentheses, exponents. Now we're doing everything. Multiplication, division, addition, and subtraction. That was the old way. It's still used in many textbooks that just haven't been modified yet. They're still using the old way of doing it, including our textbook. If you go online and read the textbook, or maybe you ordered a copy of it, I don't know. I just have the free online version myself. And I noticed that it's still out there, but there's a very long description of it to sort of clarify what this actually means. And so the clarification is sometimes referred to as the new way of doing it. We try not to use the word parentheses anymore. We like to use the letter G. G stands for any grouping symbol, such as brackets, braces, parentheses, absolute value bars, or fractions. Expressions that are in the form of fractions. We actually won't see any fractions until chapter 4, and I'm not going to be using the braces symbol in this class, so it's just not going to come up in this class. You'll see it in Math 10 or something like that, or I don't know, maybe if you do intermediate algebra or something like that. In our class, it's the brackets, the absolute value, and the parenthesis. That's pretty much for our class. And eventually fractions in chapter 4. All right. And then exponents. That's the only one that's never changed. E still means exponents. In higher level math, this includes roots, such as square roots and cube roots, which we may do it towards the, actually I don't know how far in the future it'll be. It might be sooner than you think. Yeah. So exponents include roots. So if you see a root, you consider that like an exponent. Multiplication and division are just called M. Multiply. Yeah. And then what we put, we don't make a separate line for division. We just say multiply or divide from left to right. So in other words, as you read the problem from left to right, you're going to do them as they appear from left to right. But remember, division follows the same rules as multiplication, so we might as well just call this multiplying. If there's one thing that I've hopefully made clear in the last 42 minutes is that multiplication and division are essentially the same operation, right? Just one goes one direction, the other goes the other, but they mean the same thing, right? If you can multiply, then you can also divide. You can't have one without the other, right? And then we like to group these together and just say add. Yeah. And if you look back at lessons 3.2 and 3.3, you'll recall that I talked about adding and subtracting as if they were the same thing. So I will say add or subtract. Again, left, I'm just going to put L for left, arrow R, left to right. Yeah. And remember, the rules for subtracting are exactly the same rules as addition. Right? So the new way to do it is gemma, or some people will say gems, even though this one doesn't end in an A. Yeah. G-E-M-A. It's starting to appear in books. Many of you are parents already, and you have kids that are in school, and they're going to come home from their school, and they're going to say, Mom, Dad, I need help with my homework. And you're going to go, well, the way I did it back when I was in school back in the day, it was PEMDAS. And they're going to go, we don't do it that way anymore. We do GEMMA. Yeah, G-E-M-A. Grouping symbols, exponents, multiplications, addition. This is the 21st century. The modern way. Yeah. Although back then they thought that this was the modern way. You know, every time somebody makes something, they always think that they're the newest, hippest thing, right? Okay, I remember I used to be cool once. I don't know. Example, what am I up to? 9? Use the order of operations. At some point, I should stop telling you this to simplify or evaluate or compute or calculate or whatever. And at some point, I'm just going to assume that you have to use the order of operations, whether I tell you or not. It's irrelevant. All right, so let's go. 30 minus 8. Absolute value of 7 minus 6 squared. All right, the first thing I want to mention, this is bait. Don't take it. If you go 30 minus 8, you've just ruined the whole problem and there's no coming back. It's just wrong. You won't be able to save yourself. So that's the first thing. Wait. It's at the very bottom of the order, right? So this will happen very last thing you'll do. The second thing is multiplication is implied. So if you want to put a dot right here in your notes so that you know to multiply, then by all means do it. But it's not required. It's implied. Yeah. It means that means multiply. All right. The absolute value bars are grouping symbols. So these fall into the first category. Okay. So let's do what's inside the grouping symbols first. Go to the next level, which is exponents, and do that next. And then be careful, there are no parentheses around this. There are no parentheses around that. So that means 7 minus, breathe, and then just 6 squared. It's not negative 6 squared, just like I talked about in the last example. All right, now use your rules for integers. 7 minus 36. Yeah, do you remember the rules? Let's do a quick reminder. You subtract smaller from larger, so that's going to give you 29. And then you give your answer the sign of whichever of these had a larger absolute value. 36 has a larger absolute value than 7, so we're going to give it a negative result. Now, you could do that, follow all the rules, but it's easier just to think like a human being, right? I had $7, I went to the store and I spent $36, and now I am in the hole $29. Now this is a really nice bank that doesn't charge you any fees. Okay? No fees unless it's a word problem with fees. Be careful here. This is not a negative times a negative, because the absolute value is positive. So you're going to turn the absolute value bars into parentheses. Otherwise, it'll look like 829, and you don't want to do that. Okay. Now I got to do 8 times 29. If you can do that in your head, that's awesome. If you can't, you can do it this way. 16 plus 7 is 23, 232. And I know when numbers get that big, you're probably going to want to break out your calculator. I do the same thing sometimes, but let me just make sure it's right. 8 times 9 is 72, carry the 7. 8 times 2 is 16. 16 plus 7 is 23. All right. I am running out of room down here, so I guess I'll put my answer here. 30 minus 232 is negative 202. You could do that one in your head. Yeah. You just subtract 30 and then make the answer negative. Again, it's just like your bank account. If you only had $30, but you got to pay the electric bill or whatever, it's $232. You're still going to pay that bill, right? And then you're going to be overdrawn by $202. Okay. Almost the same type of problem. This one doesn't have any exponents. It's a little bit easier. It has the brackets. Brackets mean the same thing as parentheses. And then it has another one of these implied multiplications. So that's implied to be multiplication. Again, if you like to put a dot to emphasize that. And then remember to do this last. That's the very last thing in your order of operations. You want to start here, do what's inside the parentheses first. So that'll be -6. Yeah, -10 and +4 is -6. If you prefer, you can switch to the regular parentheses. The brackets really mean the same thing. I'm not. I can go either way. Actually, I will. I'll switch to regular after I simplify it. So 5 times -6 is -30. I switch to traditional curved parentheses. -9 plus -30 is -39. Another way to have done this, if you wanted to not use parentheses, you could have gone -9 minus 30 with no parentheses. It's a little dangerous, but you should still get the right answer if you pull it off. Yeah, if you don't fall for the trap. One of the traps here is to go -9 minus 30 and then accidentally say -21. Sometimes your brain does what it wants to do, even though you know better, but your brain still does the wrong thing. You know? Especially if you've been trained. You know, the mind is just a muscle in some sense, and it just reacts. You know, it goes, oh, 30 and 9, that's 21, right? I learned that. You know, so keep your brain on a leash, you know, so that it does what you want it to do and not like kind of what it wants to do. This one's relatively simple. At least it's simple to write out. It's a little dangerous. You got to be careful with these negatives. So remember, this means the opposite of whatever 5 squared is. So you're going to do 5 squared first and then bring down the opposite sign or the negative sign. Maybe I wrote that a little bit oversized. There you go. Okay, multiply, so 4 times 8 is 32. I know that looks like parentheses in the PEMDAS thing, but that really just falls into the category of multiply. So that's one of the things about parentheses is we put them at the top in PEMDAS, but they also mean multiply down in the M level. So, you know, there's a little ambiguity there, which is one of the reasons why the acronym has been refined to try to clarify some of the misconceptions about that. All right, -25 and 32. Subtract and make the answer positive. Yeah, so what are you going to get? 7. Yeah, 32 minus 25 is 7. You probably didn't need to write that down. You probably already knew it was 7. Make sure it's positive 7 because the 32 has a larger absolute value. Almost done, just a couple more. Evaluate, simplify, calculate, use the order of operations. It all means the same thing. All right, we're moving right along. Just wait. Well, never mind. I'll keep that to myself. If you think this is complicated, wait till fractions show up. That's what I was about to say, but I couldn't hold it back. All right, same basic technique in all of these. Wait, don't do that yet. Wait. In fact, one way to help yourself wait is to write it down and put it off and say, I'll get to you later. All right, do what's inside the parentheses first. Now this time, that does mean negative 4 squared. That means negative 4 times negative 4. So that is, in fact, positive 16. Yeah, that is, in fact, a real, genuine negative times a negative. So you have to look very carefully whether or not the negative has parentheses around it. It's up to you if you want to switch to regular parentheses. If you do, you can. Now would be a good time to do it. You know 7 times 19 off the top of your head? 133. If you don't know that, it's probably wrong. I don't know. Let's see. 7 times 19. I guess, so I could be wrong. 7 times 9 is 63. Carry the 6. 7 times 1 is 7. Plus 6 is 13. I was right. Yeah. You know, one thing you can really do to help, mature your mind is to guess all the time. You see a problem? Guess, right? And you'll find out, wow, I'm getting pretty good at guessing. If you never guess, if you just, afraid to guess, you're afraid to be wrong, then the mind never really matures. It doesn't really, form completely. Yeah, so you really need to be guessing all the time. Guess, 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 guess. Occasionally you'll screw up. I mean, I screw up all the time. Yeah. That's how you learn, screwing up. Yeah. I got a PhD in screwing up. Yeah. Negative 2, negative 133. It's just like money. Yeah. So that's negative 135. It's like I spent $2 and then I spent $133. So I spent $135. You know how I always end all of my lessons? I end with variables because this class really has a target goal of getting to the variables. I don't want my battery to die before I do the variable problems. Okay, battery is on now. Last two examples. Same terminology. I'm saying evaluate, but this time I'm going to give you a value. So this is a different type of evaluating. This is an evaluating when you're given a value. Be very, very careful. I've said that 100 times in this lesson. Remove the variable and put parentheses, but do not put the negative inside the parentheses because that's this value. The parentheses represent this value, which is in fact negative, and it probably will be in this lesson. And then remove the variable here and put an empty set of parentheses. And now fill in the value with the given value of negative 5. Okay, now this looks like two negatives. But it's not. This actually means negative times a negative times a negative, because this negative inside the parentheses is being squared. So it's actually 3 negatives. And then up here, you've got a positive and a negative, so that's going to be a negative 20. So you have a negative times a negative times a negative. So that's going to be negative 25. That's a negative 20. So the final answer is negative 45. Last example. If you've been watching the clock. So I want you to evaluate this expression for these three different inputs. Be careful with B's. Sometimes if you write them too fast, they look like sixes. So that's a B, and an A, and a C. If you've had any algebra before, maybe you've seen this formula before. If not, just think of it as some expression in three different variables. So you've got blank squared minus 4 blank blank. I recommend leaving them blank for a second. Okay, that's long enough. And then now plug everybody in. All right, B is 3. A is -6. And C is -8. 3 squared is 9. Negative times a negative times a negative is a negative. Oh, that's too much for my brain. So let's just do 2 at a time. 4 times 6 is 24. And then multiply it by 8. That'll be 32. That'll be 192. If I had $9, but I wrote a check for $192, I would be overdrawn by $183. If you're not sure about that, use your long hand or break out your calculator as a check. 12 minus 9 is 3, and then bring down the 18. You're going to get 183. Okay, I'm about to end this video. I just want to let you know that you've made it a long way. Basically, at the end of this lesson, you have learned all of the basic operations, addition, subtraction, multiplication, division, and exponents, including the order of operations. So you are ready to go, right? If this was a driver's license, I'd be letting you drive now, all right? You're ready to start driving this vehicle. In my next lesson, we're going to do a lot of algebra, a lot of variables. So until we meet again, this is Dr. Jordan. I will see you on the internet.